I spent almost 40 years of my life fighting childhood cancer. Every time I am asked for by somebody to speak about childhood cancer, it's a challenge for me, a very interesting challenge. And I thank very much Maria Charlie, the Biological Society, Professor Delta, for calling me to give this presentation. So it's a challenge, a very interesting challenge, because it gives me the occasion to make a review. It's a very interesting task to make a review and present what I already know and what I learned by preparing this review. So it's a pleasure for me to share with you certain very important aspects of childhood cancer. So my purpose is to speak general about the epidemiology, what is childhood cancer, the differences between adults and children, some clinical signs and symptoms, just that you have representations of what we are talking about, challenges and opportunities of research, and finally finish with the situation in Cyprus. Now, childhood cancer is not a single disease, it's a spectrum of different malignancies. There are 12 major categories and at least 100 subtypes. There are many differences between adult and childhood cancer. Types are different. In adults we have pulmonary cancer, prostate cancer, and others. So in childhood we have mostly acute leukemias, brain tumors, Hodgkin's, and others. The causes are not known in children, or they are well known and they are preventable in adulthood. Therapies are different. Specialization is needed. There are special protocols, there are special doctors, special centers. Doctors who have to be necessarily pediatricians and then specialize in cancerology. They have to know well the pathology of childhood. And very important, whenever we treat children, we always think about the future, because we want to cure our children well, with efficiency, and have survivors with the less possible complications. Prevention is needed, contrary to what happens in the adult setting. Screening and detection is almost inexistent in childhood. And prognosis, contrary to the previous points, it's much better in children than in adults, with more than 80% of children getting cured in developed countries. It's a rare disease, less than 2% of all the cancers each year. This is an underestimation, 400,000 or something like that. The number of cases reported by the international organizations. Actually, the real number is much higher, and this is because we have lack of registries and proper diagnosis. Unfortunately, the real number is higher. The incidence in the 0 to 14 years old is 140 persons per million worldwide. In the adolescents, 15, 19 years old, 185 million worldwide. And the temporal trends are relatively stable. For example, in the last 20 years, it was in the order of 13%, which is not very much, less than 1% per year. And this is different to what we observe in the adult setting, where we see a real important increase. The most important types, acute leukemia, CNS and lymphomas. CNS, I mean central nervous system tumors, brain and spine. The three first categories are almost 60%, and the others are represented by other embryonal or other kind of tumors who are much more rare, such as neuroblastoma, Wilms, sarcoma, and others. Important to keep in mind that there is a distribution according to age. So in this slide you see the per year of age distribution. The blue line, for example, is acute leukemia, the most important group by far, 30% like you saw before, almost 30%, and it's more frequent between 1 and 6 years old. On the contrary, the red line is lymphomas, and the epithelial tumors such as thyroid cancers are more frequent in adolescents. Cancer in childhood kills more children than any other disease, actually more than all other diseases combined, as this slide shows you from data from the USA in 2018. Cancer kills 50. Cancer is responsible for 53% of the deaths in childhood, or all the other diseases together provoke less. Although there have been major advances in terms of cure. However, survival rates depend on the type of cancer and where somebody lives. This slide is very important because it demonstrates an important aspect of the inequality, global inequality. You have to know that 80% of the cases that manifest themselves yearly are in the non-developed, in the, let's call them poor countries or less resource countries, or only 20% of the cases are in developed countries. In the developed countries, only 20% die, or in the less resource countries, 80% die. This is an inequality that we cannot accept, and we need to change and improve this unfortunate situation, and we should strive so that no child should die of cancer. Few words about causes, because it's important for the following of my presentation to you today. Genetic and environment are the major categories, but let me tell you from the beginning that for most cases the etiology is unknown. There are some genetic causes, heritable and non-heritable. Up to 10% of all cancers in children are caused by a heritable germline mutation, cancer predisposition syndromes. We don't have the time to delve into this, but there are many genes that are involved, retinoblastoma, lymphomany, TP53, RB1, and others. There are also de novo situations which can happen during the embryonal life, but we also have chromosomal abnormalities of the number or structure which can cause abnormal genes and induce cancers. Concerning the causes, we know that in the adult setting, the environmental causes are very important, or in children, now at least, this is not a major impact to causation of childhood cancers, although there are some well-known exceptions, such as the ionizing radiation during the Second World War in Japan, and also the nuclear Chernobyl accidents. Ionizing radiation, X-rays in utero, CT scan, and this is important. We have to pass the message to all doctors, but also to all patients, to avoid the maximum possible diagnostic examinations which involve ionizing radiation, such as X-rays and CT scan. And also, unfortunately, chemotherapy or radiotherapy that we administer to patients, although they are necessary to cure many types of cancer, unfortunately, themselves are cause sometimes of cancer. Now, I would like to show you some images. I know there are hard images, but it's good to have some representation. And I start by explaining a bit the signs and symptoms. It's important that we know them because a very useful tool we have to get better results is to make a timely diagnosis. So it's good to have an idea about the signs and symptoms. I divide them in two categories, generalized and localized. Generalized such as pallor, tiredness, weakness, anorexia, loss of weight, cachexia, fever, jaundice, pedicea, and others. And localized according to the area of the body that has been involved, splenomegaly, hepatomegaly, adenopathy, tumors at various areas of the body. It is important to be able to differentiate these signs and symptoms from other conditions in childhood. That's why doctors who take care of children and adolescents with cancer must be pediatricians. And it's a difficult task because there is a lot of overlapping. So always we have to think about differential diagnosis. Now let's see some categories of these signs and symptoms. First of all, a mass, tumor, a swelling, or a nodule at any area of the body of the child, face, neck, abdomen, and elsewhere. Let's see some example. A swelling here in the right clavicle of this young girl. Here, a swelling of the thigh, was a huge tumor, a desmoid tumor at the neck of this little girl. Here you see this collateral circulation of the veins of the upper right thorax. It was a thoracic neuroblastoma. There was noisy respiration, worse during efforts, and the chest X-ray showed a large opacity at the upper right lung. A case of plexiform neurofibroma in a child with neurofibromatosis type 1 is the most frequent cancer predisposition syndrome. More typical clinical images of people with NF1, like this one here, armpit freckling, iris lesion nodules. This is an example of osteosarcoma of the skull in a young girl, rhabdomyosarcoma in this child. This patient of ours had a massive swelling of the right thigh. It was a sarcoma, Ewing sarcoma. Typical examples of tumors at the neck can be cervical lymphadenopathy, can be lymphomas, leukemias, and others, sarcomas. Supraclavicular masses must always be explored. Typical case of a Wilms tumor, nephroblastoma. You see the swelling at the left side of the abdomen. I show you this picture. It was published by Mr. Wilms, who operated the first nephroblastoma in 1898, and this is the historical photograph of the first Wilms patient. This is an embryonal rhabdomyosarcoma, a tumor which grows within a cavity and manifests when it goes outside. A second category of signs and symptoms is pallor, persistent tiredness, fatigue, loss of energy, behavioral changes, weight of loss of the child, persisting vomiting, anorexia, hemorrhagic syndromes including bruises, pedicea, dystaxis, hematuria, gingival, or any other bleeding, like the patient you see here, which was one patient with acute leukemia. Gums infiltration by leukemia with bleeding sometimes, typical images. This is a typical raccoon eyes or band eyes. We can see in some metastatic tumors like metastatic neuroblastoma. It's periorbital ecchymosis that you can see also in other kind of diseases. This is a very serious condition, a disseminated intravascular coagulation, which can be manifested right from the beginning of the disease or during the course of therapy. Also pain, which is persisting, generalized or localized, progressively worsening, or that wakes up the child in the night. It's very important and needs investigation, especially if you have also or alone limping, ataxia, or balance problems, recurrent fever, unexplained fever of unknown origin, or recurrent infections, headaches which are frequent or may not be with or without vomiting, especially in the morning, or that they wake up the child in the night, accompanied or not with strabismus, diplopia, blurring, or other vision disorders. That means whenever we have such kind of abnormalities, they need investigation. Here is a case of embryonal rhabdomyosarcoma of the left orbit with a tumor growing behind the ocular globe, pushing out towards the eye. This is a classical case of retinoblastoma. You see bilateral on the image to the right. It's a white papillary reflex. It's a white process appearing within the pupillary. It's typical, it's pathognomonic, like you see here, of retinoblastoma, which can be sporadic or hereditary. This was the first part. I wanted to give you an idea of the epidemiology, the clinical picture. Now, let's see what people can do against cancer. Can we hope? What are our chances? What history can teach us? If we make a historical, let's say, review, first Hippocrates described very well cancer, breast cancer, and the ancient Greeks operated. They had excellent tools. If you see expositions with surgical tools of the ancient Greeks, they are very similar to what we have today. And I call it cut out, remove the enemy. That was the first established therapy. But it was not enough. And many centuries later, we have radiotherapy with Marie Curie in the beginning of the 20th century. And I call that deliver killing the energy to the enemy. It was perfect. The results were good. And not many centuries later, few decades later, in 1940s, chemotherapy was discovered. And there we make carpet bombing. Chemotherapy is not a good therapy, but it's a necessary therapy. It's a barbaric therapy, I call it, because we bombard the body. It's like carpet bombing during the war. We kill the abnormal cells. We make a lot of damage to the normal cells also, and we hope that only the normal cells will grow back to normality, and that the cancer cells do not grow. Well, sometimes they do grow, or quite often they grow, but that's the only thing we had till that moment. Now I'll make a small break, tell you a small story, a very interesting story, to see why we can hope, and I think we can hope in many other ways. You have to know that the discovery of chemotherapy was completely coincidental because the Germans, they bombarded US ships who were loaded illegally with poisonous gases which were forbidden during the Second World War at Bari in Italy, and gases were liberated, and American sailors put bone marrow plastic. And the scientists realized that there are substances that can kill cells. So tests began on cancer cells in patients, and we arrived in the era of chemotherapy, and Dr. Sidney Faber, the father of modern chemotherapy, was able to to use the first chemotherapy in children with leukemia, and he was able to succeed with chemical substances, the first remissions of leukemia. This is the first paper in 1948, I think it was New England Journal of Medicine. He used aminopterin and methotrexate in the late 40s, and these children entered remission for quite some time. So what does the travel through time teaches us? Why did I tell you all this? Because if we see that after many thousands of years of humankind history, because let me know that cancer was already known in Paleolithic times. If you see mummies from Egyptian times, we find cancer. So cancer is not something new to humanity, but it was only when Hippocrates, born in the 460, died 370 before Christ, who described very well, he did the first established therapy. Then we waited many centuries to radiotherapy, and then a few decades later, we arrived to chemotherapy in 1948, and very quickly, we arrived to precision medicine. So after a slow start and rapid advances, we are now today witnessing an exponential growth, and I consider myself lucky because in 40 years I saw huge difference that many other people, many centuries and thousands of years didn't see them. So we can hope a lot because there is an exponential growth in the progress of our fight against cancer, so we can hope. So we were for many centuries with non-precision medicine, surgery, chemotherapy, radiotherapy. Now we have precision medicines with all those agents and others. I don't have the time to go through them. But what I want to do with you today is, first of all, to see our vision. What is our vision? Achieve percentage of cure more than 80 than 90%. We want actually to cure all children, but for the moment we want to go beyond 80%, which is the average in the developed world. We want to find cures for refractory cancers. We want to be less toxic, cure our children and young adults, but cure them well with less harm and long-term sequelae, and help the low and middle-income countries to benefit from the same advances like the more developed world. Now, get ready for a hard ride. I will try to be as gentle as possible, as quick as possible. I will present you a series of challenges, would be why, and the opportunities. Each phrase that you will see could be the lifetime work of many scientists. I just make an overview because I see a lot of researchers. There's a lot of research opportunities. There is a lot of work to be done here. So let's go for it and see. Perhaps somebody will get an idea for a future project, and if this happens, everybody will be very happy. So, number one problem, challenge, lack of registers. I mentioned it before. We don't know the real problem of cancer all over the world. What we can do, we can create cancer registries. We did it in Cyprus. I will speak about it in the end. Registries to explore the data for a reduction of the burden. The registries can give us a huge amount of information that we can exploit. The etiology. We don't know the etiology of childhood cancer. So if we don't know the etiology, we cannot make prevention. So we need to explore the data from data registries, from biobanks, from cancer registries, from descriptive and analytic epidemiological studies, so that we understand the mechanism and hopefully find the causes so we can do prevention. Because prevention now is very limited and is contrary to what happens in the adults. However, no matter how limited it is, we know that the challenge is to find the causes and make better prevention. Better prevention is a challenge. But we already know certain things. Breastfeeding. We know that breastfeeding during the first 6 months of life of the children is associated with at least 30 to 40% less risk for childhood leukemia. So let's encourage breastfeeding even more than we do now. We know that there are vaccinations that are protective against various cancers, HPV, hepatitis. So we can do these things. We know that there are association of higher risk with certain lifestyles of parents. So we have to encourage our young and less young people who want to make children to have a a lifestyle as healthy as possible in order to diminish, hopefully, chances for any abnormalities to their offspring. Also, a very important aspect in the prevention opportunity, we have to educate very well our children from very early in their life so that when they become adolescents or young adults or older adults, they will be well equipped in terms of knowing the right way of the healthy style of life, and that will protect them for their whole life. So that is important also. Toxicities of therapies, a big challenge. As I mentioned before, the therapies we are using today are not good. We are not happy with them because they are toxic, they cause problems, and they are inefficient. So we have to get improved there. Meanwhile, we have to try and find the less toxic possible therapies, but without diminishing their efficiency, because we have examples in the history of the protocols of childhood cancer, for example, in lymphomas. In the 80s, we removed one drug in order to diminish sterility problems and second cancer problems, and efficiency suffered, we had more relapses, so it was abandoned. So we have to diminish toxicity, but not to diminish efficiency. How we can do that? The escalation of therapies. There are many other methods. We can discuss it if you want. I'm always there to analyze this, but it is important that we give resources to discover less toxic therapies. Lack of progress in certain types of tumor, it was already mentioned before. In adults, but also in children, there are certain kind of cancers, for example, brain tumors, diffuse infiltrating pontine gliomas, high-grade gliomas, like it was mentioned before, neuroblastoma stage 4 metastatic advanced sarcomas. Here, the percentages of cure in childhood are no more than 50%, or in leukemias in the 1960s, almost no child survived, or today more than 86% in Cyprus, for example. So in lymphomas, we have 95%, thyroid cancer, 100%. So we need to find ways to improve the situation here. There are many ways: DNA exploration progress, the molecular identity of the tumor, targeted therapies. We're going to see this more in detail later. We also have the challenge of research programs, because most of the research which is being done now is done in the cancers of adults. Very little resources, very few resources by the pharma industry are given for discovering new agents in children, and it's understandable because 90% of cancers occur in adults. So unfortunately, there is not enough research for new agents in children, and this is a challenge, and we have to see how we can fund fundamental research and studies specifically for children, collection of specimens in biobanks to explore more the biological childhood tumors and identify specific genomic alterations in pediatric cancers. That's an opportunity to work on it. A consequence of what I said before is the lack of innovative therapies for children. The genetic alterations of childhood cancer are much less than the genetic alterations that we find in adulthood cancer, so this is a problem. So we have to see how we can use these innovative therapies, gene therapies, gene editing, like CRISPR-Cas9 or prime editing, how we can use better, how we can use them better in childhood. Another problem, I already mentioned it, that we have only a limited number of druggable mutations. Druggable mutations are mutations for which we have a medication which can counteract the abnormal product of the abnormal gene. Abnormal genes produce abnormal proteins which induce cancer. So if we can block the activity of an abnormal protein produced by an abnormal gene, we can have very good even cure. We have examples, we will see them later. So we have to see how we can do that, and also see how we can use gene editing with CRISPR-Cas9 or base editing in childhood cancer. Few words about these very important evolutions. I'm sure you are aware of conventional CRISPR-Cas9 gene editing, very important, but because there are double-strand breaks, they can lead to off-target effects. Now we have the base editing, which is minimizing the errors, perhaps it's better. Recently, a couple of days ago, I read that in the United States, a revolutionary therapy was used with genome editing, but instead of making one of these two methods, instead of cutting and replacing a gene or repairing the gene with a base editing, what they did, they inserted it in patients with sickle cell anemia. They inserted the normal gene for hemoglobin, so the abnormal gene stayed there. They inserted in the DNA of the patients the normal gene, and the progress was fantastic because they could produce normal hemoglobin, therefore the problems of sickle cell anemia were reduced. So this is fantastic, and maybe in cancer we will see that one day. So you see how quickly science and medicine progress in this field. Agnostic therapies. What are agnostic therapies? Till now, till recently, therapies were based on topography, where the tumor appeared, and on histology, what kind of tumor was appearing on the histological, morphologically, what tissue was it, what kind. But now, we have more and more the molecular identity of the cancer, but we need also, in many cases, the molecular identity of the patient. So tumor agnostic therapy is a treatment based solely on the genetic makeup of person's cancer rather than the type or body location of the cancer. This is very important because sometimes you can have cancers with the same genetic makeup appearing in different areas of the body. For example, Pinhead or Ewing's tumor, the family of Ewing tumor. You can have them in the brain, you can have them in the thorax, you can have them in the bone, you can have them in the soft tissues, but you can use a similar therapy. So agnostic therapies is the future. That means practically therapies based mostly on the molecular identity of the cancer, and it's very important to be able. We have many examples of such therapies. We are not going to delve into detail. The most ancient, it's already 20, 30 years, the imatinib, which works against the BCR-ABL1 fusion gene, the abnormal, which is produced by the translocation 922. So there are many others that can be used in this manner. Another big field challenge is how we can fight the deception that cancer cells do to our defense mechanisms. That's very important. So we enter the big field of immunotherapy. There are many methods: CAR T-cell therapy, checkpoint inhibitors, anti-HD2, antibody-drug conjugates. There are many. We are not going to delve into them. T-cells normally in normal people who don't have cancer recognize cancer cells and they kill them. But cancer cells are clever, and they can develop mechanisms that allows them to hide from the cancer T cells. But if we can modify the T cells, and there is a method which is revolutionary, the CAR T cell method, which can genetically modify the T cells of the host, of the patient, so that it will recognize its own cancer cells and kill them. This is a diagram where scientists, doctors take T cells from the patient, they modify them genetically, they multiply them, and then they refuse them to the patient. And this modification allows the patient, they're autologous, so we don't have the problems of allogeneic bone marrow transplantation with graft versus host disease problems, huge problems that they are managed, but they're still problems. But in this case, because it's autologous, the newly transformed, modified genetically cells of the patient fight their cancer. And the most well-known example, it was a breakthrough. It was in 2015 at Great Ormond Street, when a young girl who was otherwise to die, she was on palliative care. She was treated with CD19 modified T cells. They were able to recognize exactly these T cells, the leukemia of the child, and this child got cured. And this CAR T-cell therapy is expanding to many other tumor types now, so it's a very promising field. Also with checkpoint inhibitors immunotherapy, where we use various medications, antibodies mainly, which allow T cells recognize better the cancer cells. Actually, they block, as you see here, they block the mechanisms, the antibodies, or the proteins that the cancer cells express on their surface. They block these molecules. Therefore, the T cells can recognize the cancer cells and kill them. So it's very important. Now, I finish with the challenges, and I apologize, but it's important to see what are the challenges and what are the opportunities to detect the cancer predisposition syndrome. This is a very important topic, and we can actually immediately, and in Cyprus, we started working on that. Among the children with cancer in Cyprus, up to 10% are related. They have cancer predisposition syndromes. That means that in our population, we have a good percentage of cancer predisposition syndromes. So we have to recognize these cases. Why we have to recognize them? Because if we find the index case is a patient. We have a number of examples in our clinic, such cases. If we recognize an index case, a child who has a cancer because inherited a cancer predisposition syndrome, a gene that induces cancer, then we can climb up the family. And if we find that there is a cancer predisposition syndrome in the family, then we can establish a screening, a regular long-term screening program for the family. And it was proven, there are excellent studies for it, in families with Li-Fraumeni syndrome, in the TP53 mutations, that in these families, if you have a regular screening program, deaths in these families are almost zero. If you don't do it, then you have many deaths. So it's very important, and in Cyprus we can do that. So it's a big challenge and a great opportunity to have a significant win against cancer. Challenge number 12, increase the number of survivors, but also improve survivorship. Survivorship is the quality of life, of the survivors. So it's not enough to cure them, but to cure them well, so that their their quality of life is good. So I mentioned the opportunities I mentioned before. So we have to increase the awareness about non-toxic protocols, but also increase the awareness of the general practitioners, of the adult physicians, so they take well care of the survivors, but because the survivors are increasing in the population. It is estimated now that in the European Union, more than 1 out of 500 adults is a survivor, and these survivors, unfortunately, more than 60% of them, they have different kinds of problems because of their cancer, but also because of the therapies that they receive. Last and not least is what I mentioned before. A big challenge is to offer to countries with less resources what they need to help them arrive to the same results like we have in developed countries. And I finish my presentation about Cyprus. So all this was good. We talked about it. I presented to you ideas, challenges, opportunities. Perhaps we can start a project to meet one of these opportunities and make gains in this field. But what is the situation in Cyprus? The situation till now was never before examined. So what we did, we wanted to know what happens in the 0-19 years old, the incidence, the temporal trends, to compare worldwide, and perhaps see what is the etiology in our country, what is the risk factors. This paper from my team was published in August 22, so its results very recent. We established, first of all, after many years of difficult work, the Pediatric Oncology Registry of Cyprus, we call it PORCI. It includes patients 0 to 19 years old with hematological malignancy and solid cancers. It's a population-based registry, very important. So all our population is covered, and this is an advantage of small countries because we can control all our population, which is not the case of other members of my team who live in Germany and the United Kingdom. We don't have this capacity to control very well their population. So the data quality, the quality of our pediatric oncology registry are excellent. Microscopic verification proportion is 99%. Death certificate cases 0%. So incidence versus mortality very small. So excellent quality indicators, and this is very good for our country. And what did we find? So for this 20 years period, there were 843 cases, 42 number of cases in this age group 0-19, 42 new cases per year, and the percentage of the cancer among all our population, 1.5%. So for every 100 cancers, 1.5% childhood cancer. More boys and girls, male to female ratio 1.2. More frequent groups, leukemias, lymphomas, specified epithelial tumors, mostly thyroid cancer in Cyprus, and then CNS tumor. This is different than in other countries, where although leukemia is number 1, number 2 is CNS tumor, and then is lymphomas, and then the others. This is a particularity of Cyprus. If we see by age groups, we see that the most cases occur in the 15 to 19-year-olds, then 0-4 years old, then 10 till 14 years old, and then 5 till 9 years old. Now, again, if we see per year of age, we see that leukemia is the blue curve. We see that from 1 till 6 years old, most of the cases. But if we take lymphomas and thyroid tumors, we see that in the adolescents, there is an exponential rise of the incidence. Now, if we take the whole period and we examine the trends and we see the annual percentage change, we see that for all the cancers in children in Cyprus, although the incidence is among the highest in the world, however, there is not a peak. It's relatively stable through the 20 years time. There is one exception. This exception is thyroid tumors, and the annual percentage change is 7.6%. So you see through the years from 1998 till 2017, you see how exponentially the number of childhood thyroid cancer, this is alarming, and mostly affects the 15, 19 years old. Let's see a little bit more data about this problem. Our incidence in thyroid cancer among the world's highest, I suspect is number 1, if not number 2. Increasing trends in males and females 15, 19 years old. The annual change is very high, 7.5%. Almost 10% of all cancer types of this age group. Girls are almost 4 times more often affected. Papillary type is the dominant type. Almost 4 times increase in the metastatic cases, so it's not a problem of overdiagnosis, but the true increase of incidence. But fortunately, we have 100% survival. This is important. Previous cancer therapy and cancer predisposition syndrome, for cancer predisposition syndrome was not assessed, but previous cancer therapy did not contribute in this case. So our conclusions for Cyprus, among the world's highest, only Italy and Belgium have higher than us. The differences of the most frequent types, as I mentioned before, leukemia is most frequent as elsewhere, but lymphomas and thyroid cancer more frequent than brain tumors, which is different than what is described elsewhere. There were not significant temporal trends for all cancers together, except for thyroid cancer, where we have among the highest incidence rates globally, significantly increasing temporal trends, mainly affecting girls and the 15, 19-year-olds. We have particular patterns important that raise etiology questions. We need to search for causes, genetic exploration, environmental or genetic factors, and we have now novel insights who allow us to move forward. What happens worldwide? Challenges in managing childhood cancer are important in Cyprus, but also the same problems are existing elsewhere. There are opportunities for intervention, so we need to act. We have to boost the research, fundamental, etiological, and clinical in this field. We have to find the etiology. Prevention, we need to prevent better, prevent more. And specialization everywhere, as I mentioned before. In Cyprus, we succeeded in this field to a big degree. Therapy has to be less toxic and provide equal access. Now what? What do we do in Cyprus after this review, after this finding and comparison with the situation worldwide? What do we do? Why in Cyprus we have such high incidence rate is not answered. But of course, this is not answered elsewhere also. We know the factors, I already mentioned them: genetic alterations, environmental therapy, infectious agents, hormonal, dietary. But what did we think after studying Cyprus and living in Cyprus and working 32 years with children with cancer? Where did we concentrate our research hypothesis? Obesity and overweight, ionizing radiation, arsenic, and cancer predisposition syndromes. Obesity and overweight. In 2015, the 69 years old, obesity in this age group, obesity affected only 20%. In 2018, 43%. Many ramifications, negative ramifications for the present and for the future. So obesity significantly increased in all ages in Cyprus, but also in mothers. So there are data that show that obesity can be linked in the adults. Is proven. At least 7 types of the adulthood cancer can be caused by obesity, and 20% of adulthood cancer are directly linked to obesity. In childhood also, now we see more and more publications incriminating obesity. It's not yet proven, but we have to search whether obesity plays a role in our countries. Ionizing radiation, X-rays, radon, X-rays, I already mentioned, we have to minimize the ionizing radiation for examination. Arsenic is a problem in Cyprus. It's not well known, but arsenic is increased and it can be carcinogenic. And there is a rising trend, especially in Nicosia district. What repercussions this has, we don't know it. And cancer predisposition syndromes, I already mentioned the importance and what we have to do for it. Final conclusions. Challenges are important, international opportunities are many. We have to boost research, fundamental, epidemiological, clinical. We have to find causes and develop prevention. We have to manage children in specialized centers, fight inequalities, equal access to standard of care, innovative therapies for everybody. Professionals, clinicians and other for childhood cancer should be trained continuously, lifelong, and we have to improve survival and survivors. Thank you very much, and I apologize for taking some of the time.
So due to the pressured schedule, I think we should break now, so we should have a coffee for 15 minutes, and then we'll follow up with a short talk and continue our schedule.
Yes.
And questions will be addressed also at the end or during the coffee break.
If you want now some questions, I think it's important.
If
anybody wants any question, because later,
me,
I'm ready. It's up to you. You are the cheerleader. You the boss here.
Where is the arsenic so that we can avoid it?
It's in the ground, but it can be elsewhere also. We are studying it now. I cannot give you more information. We discovered this recently. We saw the publications, studies were done, and we are in the process of examining, and we are developing a tool of the geographic distribution of the cases and correlated with the distribution in the soil. So I don't have answers for everything now. I just gave you our hypothesis. Maybe it's wrong, but it's hypothesis. But if we will be able to, with the tool we are developing now, hopefully I will present it to you next year, the geographic distribution of the cases according to type and geographic unity and concentration of arsenic, then we can answer the question. Any other question?
Yes, you mentioned proton therapy.
Yes.
Do we have in Cyprus for?
No.
Io non avevo scritto qui, mi avevo previsto la massima entusiasmo mattino e poi mi ha detto che non ero di sì. In realtà ma avete con DIC syndrome, chiamano DIC syndrome, disseminated intramuscular calculation. Ανέχεις καρκίνο πολύ θανατήξεις DIC θα το λέμε τα γλώσσα apply.
Εσάς καταλάβω.
Ανέχεις
το μικρόφωνο να πω.
Καρκίνο μπορείς να αναπτύξεις DIC, το λέμε τα γλώσσα apply. Που έχεις τα cells κατακίσχες.
Disseminated intravascular coagulation is a common final pathway of many diseases: trauma, burns, cancer, chemotherapy, surgery. It's a common final pathway of the stabilization of the coagulation mechanism. Okay? So a cancer per se, before treatment, can cause DIC. We see biological or clinical. Therapy can cause it, and many other diseases. That's it. There's no other. You cannot develop DICC just on that. I'm not aware of that. Disseminated intravascular coagulation due to what? APOD. Έχουν clotting factors. Everybody has clotting factors. You mean no relation. Κατάλαβα τι είναι, κατά πόσο το DICC... Όχι, το DICC is a purely clinical situation, the terminal pathway or whatever it is called.
Now, what is